Yeah, please. Mhm. Did Yeah, it should be. But if you have a different folder, then you can give the complete location of that file. Okay. So yesterday I have given couple of assignment, couple of tasks. Not an assignment. I can say like it's just a like a prerequisite for the joining the class. I would ask one question: how many of you get a chance to have a look into that, like statistics, 8 videos, and that EDA techniques? At least one EDA or two EDA. Did you guys get a chance to run that one or two EDA? It's just executing the thing. It's not about that like you have to write a code. Mm-hmm. Okay. Okay. Can you please share your screen? I might be I can help you in that. Yeah, please. So if this kind of issue is coming and it's something like you are getting blocked, then feel free post in the group. I will help you to don't be unblocked kind of thing, because I know everyone is working fellow, so I do respect your timing and don't want to Zomato.csv. Can you ma'am go to that directory? I wanted to see what other things is there. And yeah, and can you go to the Zomato wala folder ke andar? Oh, okay. हाँ. No, this is IPYNB checkpoint. That is not needed. Whenever you will create a Jupyter notebook, na, any folder, inside of any folder, then automatically this IPYNB file will get created. Okay, can you ma'am open this Black Friday wala folder? Go to the Black Friday. Here is there. The file is there. Okay, Zomato wala data I will upload. It seems like there is a file is missing. Everyone is facing the same problem with Zomato. Have you tried that? Anybody else? It seems no one has tried. Okay, so I would request Rumula, like instead of blocking, can you means you should try this Black Friday, right? Uh, uh, Instead of waiting all this. Yeah. Anyways, please try once. Like you will get a chance today as well. Please try that because this is important, right? Yeah. You can't run this from here. Like your system, you have to open in the Jupyter notebook. Yeah. Cool. That's awesome. Please have a try once. I think someone has raised a request as well tomorrow, yesterday. They don't have the access. I have given the access as well. I think Divya and Rupa, you guys got access about these things. Um, yeah. So I was hoping you guys have a tried, but no worries, you have not tried yet. Okay. Seems like it is fine. Now I am just going through. Let me close this. Huh. Wait a minute. So yeah, so where we were discussing about the adjusted R square. Okay. So adjusted R square, and why adjusted R? Okay, let me ask you a question. Let's see how many are present, mentally present. Okay. Uh, what is linear regression? And what are the different type of machine learning algorithms are there? Anybody, please go ahead. Yes, yes. Anybody, please. Right, wrong, I don't care. Please keep the answer. Because it's not like that I am delivering the content and you are not accepting the content. That won't be the case. So I want whatever input I am passing, I'm expecting the output as well. What are the different type, and whoever will deliver the output, they will learn. It's not like that means if you are not delivering the something and you are learning something anything, right? It's not the case. You have to deliver the things, right? You means like it's not like the teacher and student kind of thing. You are in the class nursery student and I am your teacher and I'll sit with you 24/7. You guys are enough mature. You know what is the important of the class. What you know over the weekend, Friday, Saturday, Sunday, we are taking 2 hours of classes, and what is the important of these 2 hour classes? So you can do some kind of productive work in these two hours. Why you are wasting your 2 hours if you are not able to deliver the content, if you are not able to grab the things whatever I am passing to you, right? So invest your 2 hours somewhere else where you can put the product, show the productivity. That I always will be there. Like, see, I used to follow these things. One concept, like, if you are not present here, where are you present? That's the first thing. Wherever you are present, show your presence there 100%. Either you are watching the movie, playing the game, show your 100% there. But at least do let me know where you are present. If you are not present here, if you're not present 100% here, right? So yeah, anybody, please let me see how many of you are able to understand what are the different type of machine learning algorithms. Yes. Very good. And in supervised, what are the different type of machine learning algorithms are there? No. In supervised, there is a two type. One is regression, another is classification problem. Regression means where the target column is continuous in nature, like their cells. Cells is continuous data. But when the categorical data we are going to deal, that is called classification problem. Yeah? Cool. And what is unsupervised machine learning? Nahi. Where the target column is not given, that is called unsupervised machine learning problem, right? Okay, very good. And I was talking about yesterday, like, did you guys get a chance to have a look into that 8 videos as well, Trumala? I'm especially asking, like, I think like you are, uh, yeah, very good. What do you understand by the probability distribution function, PDF? Okay, so normal distribution is also a part of probability distribution. Yeah, statistics. Normal distribution is the type of probabilities. Yeah, 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 Divya, go ahead. If you have, yeah, no worries. Okay, please do go through that 8 video. This is very much important. So then only we can proceed with this. Otherwise, it's very hard to understand. Okay, now we are going to discuss about uh 1 minute. We have 75 adjusted R square. Okay, what do you mean by the adjusted R square? And what is the R square? First tell me what is R square, then go ahead with the adjusted R square. Yeah, Trumala, you can go ahead if no one is. Yeah. Very good. Means R square is the evaluation matrix, I can say, with which we can say our model, our state line, which we are doing, how accurately or how much it is covering the data points. That is called R square, right? And what is the problem? What was the problem in R square? No, when we increase the number of features. Hmm. So the R square matrix is not a right or optimal or matrix to evaluate any kind of what we call, say, to evaluate linear regression model. So for that, we introduce adjusted R square matrix, and adjusted R square is performed well. Now we are going to discuss about one thing. Let's suppose, let me take my whiteboard. Okay, I have not started recording. I started, yes. So let me talk about this. Let's suppose after applying the machine learning model, we found one thing. This is our distribution of GER, if I'm not wrong. This is our distribution of data. Now, even though you applied a best fit line, even though you applied the best fit line, but it somehow, some cases will be there, which might be possible that this line is not able to define that point. Let's suppose some data is there. So if I will check the residual between this point and this point, this is very high, right? This is very high. Though if I will try to define this point as well, then might be I have to prepare my best fit line like this. Then in that case, this line will be very far from this point. These points, this point, this point, means just to cover this line, these points are getting detached, right? So in order to overcome this kind of problem, what we can introduce a penalizing factor or regularization techniques. Sorry, penalizing factor or regularization technique. Regularization technique. What do you mean by the regular? Okay, what do you mean by the penalizing? Penalize means what? It's an English word. Just I'm asking, what do you mean by the penalize? Okay, so in just take an example of your child or any child. So in that case, what we have find, like when the child is getting grown up, let's suppose this is the small child and he is just growing up in his life. Now he will do blunder of mistakes while growing. Sometime he will do something, sometime, and with the time, your means his parents' responsibility is to what I can say, to to teach him ki what is right, what is wrong, and what should not do by this guy. So next time onward, this child will not do the same activity. Just for example, so this is called penalizing. Means let's suppose if tomorrow I taught to this child, don't do this thing, don't do this bullshit kind of thing. So tomorrow, if he is doing the same mistake again, then I will do the penalizing, mean punishment. I will put a punishment to this guy. I will give the punishment to this guy and this child, and then next time onwards he will learn, okay, I did the same mistake, so I got a punished, right? So in that case, the next time onwards he will not do the same mistake. So these kind of things we are going to introduce in kind of machine learning techniques as well. That concept is known as regularization. So if how the regularization is getting work, so whenever we are building the machine learning algorithm, on top of it, we got it. Like right now, we have created our linear regression model, no doubt. Up to this, we are very good, right? Now today, I'll give you one assignment as well, and in that assignment, you have to apply the linear regression algorithm. That's the only thing is there, and codes and everything is with you. Data only will get changed. Problem statement will get changed. That anyways you have to do. Now we understood, okay, we got the best fit line, but it might be possible at the some scenario this line will not able to read or not able to predict this data, right? In that case, we can apply the regularization. So regularization, how the regularization is going to work, we are going to introduce some of the weight on that line so that this line can understand this as well, this point as well. So these things is coming under the regularization. And how regularization is works, just try to understand. So it look like I have taken an example as well. Regular, just a minute. From here it is getting started. Yeah. So how the regularization is getting work? Uh, okay, I will talk about the multicollinearity. I think I missed this part. I will talk about after regularization. But before that, this slide is already with you. Please watch that in your slide if you are not able to see from here clearly. So what is regularization? When we use the regression model to train some data, there is a good chance that model will overfit. Overfit means what? What do you understand by the overfit? Means you are performing well while I am taking the exam, but whenever you are going for interview, you are not able to crack the examination. This kind of scenario is known as overfitting. Means your model is performing well with your trained data, but it is at the same time when I am passing my test data, my model is not performing well. This kind of thing is called overfitting. So overfitting means what? Means you know what is going to, it might be possible you are less confident in the testing and you are more confident while I am taking the exam, right? That could be also one of the reasons. So when we use the regression model to train the same data, there is a good chance that the model will be overfit in the given training data set. Overfit means you guys understood. So regularization helps to sort this overfitting problem by restricting degrees of freedom of a given equation, that is simply reducing the number of degree of a polynomial function by reducing their corresponding weight. I will talk about this, don't worry. This is very much jargon word. So just in case, just to make you understand what I'm planning to do, just try to understand. This is my best fit line, and this is my random data distribution. This is my random data distribution. Now just try to understand what is the regularization does. Let's suppose what I'm trying to do, this straight line equation. What is the equation of this straight line? Can anyone tell me? Y is equal to mx plus c, right? This is the equation of straight line. Now just try to understand, I have to predict this point, I have to predict this point, but my predicted point is this, prediction point came this, and actual point is this. But what is the difference between these two things? It's called residual. So if I want to minimize this residual term, what I can do, if I will introduce some constant, which is called lambda, just focus on this point. Some constant if I'm going to introduce, and this constant will be learnable parameter, means with the time it will get vary. Okay, with the time it will get vary. So what will happen? So let's suppose the difference is high, then line will automatically shift on this point, and it will able to learn. This is called regularization. We are going to apply some constant, right? Same thing is written here as well. When we use the regression and the data transfer model, overfitting and returning data, the regularization help to solve this overfitting problem by restricting the degree of freedom and give the equation simply reducing the number of degree of freedom of the polynomial function. This is just for example, it's a simple linear regression, but it can be polynomial as well, because x1, x2, x3 might be possible. So polynomial function by reducing the corresponding weight. So in linear equation, we do not want huge weight coefficient, as a small change in the weight can make the large difference for the dependent variable. Okay, so this is the same thing has been written here as well. So in the linear equation, we do not want huge weight coefficient, as a small change in the weight can make the large difference for the dependent variable. Why? So regularization constrains the weights of the such feature to avoid the overfitting. Simple linear regression, this is our multiple linear regression. So using the what we can say like this is our multiple linear regression formula, right? Equation we have seen. Now so to regularization model, regularize the model is shrinking the penalty, shrinkage the penalty added to the cost function. Let's means what we are trying to do. Let's suppose if my model is making mistake or error is very high, simply we are going to add a penalty on the model, so that next time onwards it will reduce the it will try to reduce the penalty, so it will not do the mistake. So in order to apply the regularization, and see, this regularization techniques is common for any kind of machine learning techniques. Either you are going for the supervised or unsupervised classification or regression algorithm. All the cases, this regularization techniques will come into the picture. Now, but the name will be different type of regularization we are going to apply. But in linear regression, we have a ridge, lasso, and elastic regression. Elastic regularization. I will talk about the ridge, lasso, and elastic regularization techniques. But as of now, just try to understand what is lasso. Lasso stands for least absolute shrinkage and selection operator. This is also called L1 regression. L1 regression. What we are trying to do in lasso regression, penalize the model based on the sum of magnitude of coefficient. Did you guys understood what do you mean by the sum of magnitude of the coefficient? Means we have an equation of this line, a straight line equation we have seen. What is that straight line equation? Y is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 and so on, and plus c. At the end, constant is there. So in this case, what we are trying to do, we are going to apply the means this is our mathematical expression of any kind of best fit line. So in this best fit line, what we can do, we can introduce a penalizing factor with lambda into summation of all the coefficient means summation of m, and where I is equal to mi is equal to n, and this is the our final lasso regression model. So here we just added a penalizing factor in this equation, just added. So see, when this is the equation, and if there is a less value, then this value will be positive, and if it is a high value, means less and high, just try to understand in that way. So this is our best fit line, right? This is our best fit line. So in this case, the model predicting less and we want high. So this value will get added in that, and the value will be become equivalent to this. Similarly, here is less. So this will, sorry, similarly, here is high. This is the high value and I want less. So it will minus, subtract the things in this. So with this way, we will get the better model. I will show you how we are going to say, like how I'm going to say this model is the better than the previous model after applying the regularization technique. So one of the regularization techniques is what? We are going to apply the lambda. Lambda is the constant. I will talk about these things. Lambda, don't worry. So lambda, we are going to apply the summation of all the coefficient. So where lambda is the shrinkage factor is just a constant. So if you are going to make the lambda is equal to 0, then it will equivalent to the previous one, right? So hence, so lambda regularization techniques is this one. RSS, residual sum of square, plus lambda into summation of this one. So this is called lasso regression. No need to worry. These things can be done by the library, but I'm just showing you what is the mathematics behind of this. Now, similarly, there is another regularization. Any question in the lasso regression? Yes. Yeah. So RSS you already having, just you are going to add one penalizing factor. In any kind of regularization, either you are going for ridge, lasso, or elastic. This in case of ridge, the penalizing factor will be like this. In case of lasso, the penalizing factor will be like this. In case of ridge, if I am talking in case of ridge, this will be just a square. That's all. This become a ridge. In case of elastic, the combination of both ridge and lasso, this become elastic. So scientists are doing all the kind of experiment, they are making different name, and at the end they found, okay, why cannot use the combination of both the things, right? Yeah. So now we are going to talk about the ridge regression. Ridge regression is kind of also a regularization technique, but here we are going to add the summation of coefficient. But here we can, okay, the problem in lasso, what is the problem in lasso? Can anyone tell me with this equation, by seeing this equation? Exactly. Very good. So it might be possible two value coefficient will be one negative and two coefficient will be positive. And if you will add at the end, the value will be 0. So no sense of making lasso regression. So that's what scientists came with the another regularization techniques, which is called ridge regression. And in that ridge regression, what they did, they applied the summation of square of all the coefficient. That's all. Just square of these things, right? And that regularization techniques is known as ridge regression. Yeah. So ridge regression, I will show you the practical implementation. See here also just a square term they added. Now just try to understand by difference between the ridge and lasso. I think I already given the example. Ridge regression is shrink the coefficient for those predictors which contribute very less in the model but have the huge weight, very close to 0. Same thing, but it never makes them exactly 0. Thus, the final model will still contain all these predictors, and though with the very less weight. And this doesn't help the interpreting. Same thing I just, whatever I told, with the same thing that has been written here. Now, why the regularization? Why we need a regularization? I think I have given already answer. Just to give the punishment, take an example of that child wala. If child is making the mistake again, same mistake again and again, what we are trying to do, we have to teach them anyway. So what we can do, we can give the punishment, right? So regularization, if anyone is saying what is regularization, it's just a punishment for your model. So regularization helps to reduce the variance of the model without substantial increase in the bias. And if there is a variance in the model, that means the model won't fit well for the data set different data training data. And the training parameter lambda control this bias and variance trade-off. So it's just a punishment parameter. Now I'm going to talk about elastic regression, elastic net. It's a combination of both ridge and lasso. Can you see this? This is ridge and this is lasso. Here just they added one more term, alpha. It's a constant. Lambda into 1 minus alpha by 2. It's a constant term, like a lambda. and here also alpha. So this alpha is the mixing parameter. Mixing parameter in the sense of combination of how much you are taking ridge and how much you are taking lasso, that kind of thing. So at the end, if I would ask you what is elastic regression, elastic regression is just a combination of ridge and lasso. That's all. Now I can show you how it is going to impact to your practical implementation. Let me execute this call. Let's execute this. Yeah, it got executed. Now let me execute this as well. I'm taking which data set? Okay, same data set. I'm taking the same data set and admission prediction. This is the data set is called admission prediction. What do you mean by the admission? Okay, let me show you. So this is the question admission. Okay, so I think this is not complete data set. Oh, it is there. Yeah. If I'll scroll here, then I can. So what is there? There is in the US, there is multiple universities are there. Many Indian people want to take admission in the US university. So there is some criteria to get enrolled in that particular university, like GRE score, to EFL score, university rating, SOP, LOR, CGPA, research, right? So based on that, they are going to predict the chances to get the admission in that particular university, right? So again, it's a regression type of problem. See, chances of admission is also a real number, right? So, 1 minute. So here is also kind of, it's a regression problem, no doubt. So I'm just going to upload this data, loading this data. This data is got loaded, and in this load, I'm just calling the describe function. What is the describe function does? Describe function shows you how many data points is present. Can you see this? Every place, and see, very interesting. Can you see this? Total count is 500. But in GRE scores, just 485, means 15 non-present value is also there. Means there is some data point where the GRE score is not present. There is 10 data point where 2EFL score is not present. Again, university rating is not present. But in SOP, there is no null value. Can you see this with this? Yeah. So same thing. So describe function will help you where there is any null value present or not. So first thing is that whenever you are going to build any kind of machine learning problem, you should do a EDA, understanding the data. So I understood the data. Oh, there is a null value. So first thing is that we have to fill the null value, right? Or else we have to remove the null value. Similarly, to EFL, there is a 10 null value. University rating, 15 null value again. So like this mean. What do you mean by the mean? Mean means in this serial number, what is the mean? And anyway, serial number is not going to impact on your machine learning model. So we can remove this serial number count. Yeah. Anybody having any question? Yeah. 1, 2, 3, 4, 5. Like this. Okay. So we can remove this column as well. I will show you how to remove. This is called EDA, feature engineering. So this attribute is not making any sense. It's just a serial number, right? We can remove it. But the GRE score, there is a NaN value. NaN means not a number. So we should treat this NaN, means we have to, without treatment of NaN, if you are trying to build a machine learning model, it will throw an error. Says GRE score having none value. So none value, we can't, with the none value, we can't build a machine learning model, right? So we have to, with this describe function, we are able to see what are the null value present. So what I can do, I'm going to get, with this data set, we can able to, okay, let me write down. I have not written here. Control Z. So let me write down by the observed observation, from the above observation, observations, we found, what we found, there is some null value, some NONE none value present present in GRE score, university ratings, and 2EFL scores. 2EFL scores. UFL score. So how we can treat this null value? See, there is a one thing. Either you can remove the null value, or else you can, if it is a continuous, see, this is based on the problem statement, this value, these things will get changed. But as of now, what I can understand, this is the university rating, right? So what do you mean by the mode? Can anyone tell me what is mode, mean, median? Yes. So how mode means, like, let's suppose we have a in data point. Very good. Most frequent data point is called mode. We have 1, 2, 2, 3, 2, 4. So what is the mode of in this data point? 2 is the mode. So similarly, in the university rating, what we are trying to do, we are trying to fill all the none value. Can you see this with this equation? If you will. So if I can scroll down, see university rating के अंदर whatever none value present, fill NA. Fill NA is the function with their mode. So what I can say, just try to understand. First, copy this line, and I am just trying to copy this, and I am trying to just show you code. I'm just showing you. If I'll copy this, I can see this is 3. Mode is 3. Can you see this? Mode is 3. So this mode value, I am going to store 0 value. 0th value I have to take. So you can see 3, just 3 is coming. So what we are trying to do, we are trying to fill all the none value. So fill NA is already predefined function. In that fill NA function, what value is coming from here, that value I am filling in the university rating wala column. Similarly, in the 2EFL score, 2EFL score is what? If you will go to the 2EFL score, what is the data? 2EFL score is a continuous data, right? So if it is a continuous data, means it's not like that mode you can fill. You can fill the mean value wherever the, okay. So just I'm telling you, let's suppose in your class, there is a 20 students are there, and the result got declared, and all the student got 60, 65, 70, 75, but somehow some of the one student missed to get the marks. So what I can predict, what will be the average of this student mark? What will be the marks? So everyone is getting 60, 65 or 70 marks, then this student will also get the same mark, might be, right? So same thing. If this kind of data it is, then we can fill the NA value with what I can say, their mean. Mean means summation of all and divided by that number. So same thing we are trying to do here as well. So 2EFL score, if we can go 2EFL score, I am just filling with their mean value. See here, I am just filling with the mean value. So what is the mean of this data point inside of 2EFL score? If I can go to this, Control C, and if I can go to this section, if I'm running this, I can see the mean value this. So I'm filling my none value, means NA value, with their mean value. Can you see this? Similarly, the GRE score, I'm just filling with their mean value, Yeah. So now if I'm checking, there is a no null value. Can you see this? Again, if I'm running this function, describe function, there is a no null value. Everything is got filled. Did you guys understood what I said? Yeah. So none value should not present. Similarly, I already told you, serial number is not any important parameter. It's just a serial number 1, 2, 3. So I can remove the column. See, I'm just removing the column, data.drop, and column is equal to serial number. So I'm going to remove and I store in the same data point. And if I'm checking now, serial number is not present. Now what I'm trying to do, I am trying. I'm trying to see the PDF. This is called PDF, probability distribution function. So any kind of randomly distributed function is always should follow the bell curve. If it is not following the bell shape curve, means there is a mistake in your data point. So you can see if I'm going to plot this all the column, one by one column I'm going to take, and here I'm going to apply the matplotlib subplot, and here I'm just trying to pass 4 cross 4. 4 cross 4 means four thing will be there. Each row contain 4 column, right? So I'm just trying to write here this plot dot subplot 4 cross 4 plot number, and here I'm going to write distribution plot. This is called probability distribution plot, and here each column, so this is the column name is coming, each column, and this font size is 40, and label I am going to give, and same thing I am going to apply, and just I am trying to plot this graph. This is the graph to plot these things, right? So now I'm going to remove my x and y. X and y means what? Independent and dependent variable. This is my dependent variable. I'm just removing data from the chance of admit, means whatever the target column, and remaining column I'm going to treat as a x. So what I did, can you guys see? Data dot drop column x column is equal to chances of admit, means chances of admit I'm just removing, and remaining data I'm going to consider as x. So just to take an example to make you guys understand what I'm trying to say. So I'm trying to say this thing. So let's suppose we have a data point like x1, x2, x3, x4, and we have y. Now we have to distribute, means we have to segregate our x and y. This is called x and this is called y. So if I have to segregate, what I can do, x may, this is complete data point, this is complete data point, this is complete data point from here to here, from here to here. So if I have to remove x and y, what I can do, data dot drop, data dot drop function I can use, dot drop function, and here I am passing my chances of examination or chances of admit, because this is my y. So that same thing I did, x में से drop कर दिए chances of admit, and y value will be what? Y value we are just considering the chances of admit, that's all. Yeah. Now again I am drawing these things, and this time it's like a scatter plot, and in the scatter plot I am saying GRE score, chances of admit, means scatter plot between the GRE score and chances of admit. We can clearly see in case of this GRE score, this is linear regression model, like okay, a best fit line can be drawn, right? In this case also best fit line can be drawn, but in this case chances of admit and university rating, you can see the university rating is 5, sorry, university rating is 5, the chances of getting admit is very high. Can you see this? Chances of getting admit in the university is very high. Similarly, if I will show you, similarly if I'll show you SOP, I don't know what is SOP and what is LOR. CGP I know this kind of number, and you can see high number is getting more chance to get admit into there. That's it. Yeah. And great, the relationship between the independent and dependent variable look fairly linear, and thus our linearly assumption is satisfied. So now what I'm trying to do, we are trying to do the standardization, standard scalar. What do you mean by the standard scalar? Anybody? Okay, no worries, I can help you. That 8 video will help you to understand. Okay, just complete that 8 video, you will understand what is standard scalar. That's what I have given you guys as assignment. Okay, how many of you are from engineering background? You can put a chat as well. Engineering background. Yeah. So in engineering, there is one subject called ED, engineering drawing. Have you, did you guys face this subject? Yeah. So in engineering drawing, what we are trying to do, just take an example of civil engineer. In the civil engineer, I'm staying like 24th floor right now in the Salarpuria, right? So Salarpuria 24th floor I'm staying. So 24th floor I am staying right now, and it is 28th floor. One building is this, right? So just for example, let's suppose if I have to draw this complete building on a piece of paper, will I able to draw entire building on this piece of paper? No, we can't. We never. So what we can do, we can do us means we can do the simulation. Okay, 5 meter ko 5 centimeter or 5 millimeter we can take, 5 centimeter we can take, right? Whatever ball size is 5 centimeter, sorry, 5 meter, I can make it 5 centimeter, scale down. So standard scaler is doing the same thing. What they are doing, they are doing means whatever data is x1, x2, x3 kind of thing, they are just doing like this, x minus x mean. Mean means the sum is mean of these things, divided by z. So z, I will talk about this with this way we are, they are doing the standardization. They are just making standardization of data points so that it will be not that much of error will come. So here what we are trying to do, we are trying to do scalar dot fit transform, and here we are passing the x. Yeah. So this is the thing, they are doing these things. And now let me show you standard scalar. Yeah, x is not defined. I have not executed. Oh. This got plotted. Similarly, if I'll execute this as well, standard scalar done. And now I am trying to create again missing data error. What is saying? XOG contain infinite or nans. Okay, there will be some none value is present, I think. So I'll talk about this VIF. Okay. Anyway, did you guys understood what I did here? Like till here is standardization. Now I will talk about the VIF. Standardization, do you understood, right? It's like a part of pre-processing, or you can say EDA. Whether your model, let's suppose you build a very basic model of V0 model. Now version 0. Now tomorrow you are building the means you put into the production and you found, okay, if we can improvise this model, means what are the techniques we can apply? One techniques I already told you, standard scalar. Standard scalar we can apply, with which our model performance will get increased. Second thing what we can do, we can apply the VIF. VIF is called variance influence factor. I will talk about this thing, how it works. Third thing is what? Third thing what we can apply. Third thing, okay, standardization is done, but VIF is done. Third thing we can say PCA. I'll talk about this PCA, how the PCA is getting work. Now, let's me talk about the VIF first, and then I can explain you remaining thing. So standardization is done. Now I'm talking about the VIF. So if you can see in the real term, in linear regression model itself, we have a multiple feature x1, x2, x3, x4, x5, and then we have y. Now it might be possible, we have how many feature? 5 feature. To predict the y, we don't need some of the x value, means x1 is not needed, x2 is not needed. So how we can get that number, means get the data, which is important, which is not important. So for that we are going, or also there is some multi-connectivity function, means what I can say, to calculate the weight of the body, what are the parameters we needed? Age we needed, and we need, what is that? Age we needed, and height. Yes, height. And we need a diet plan, exercise, whether these guys are doing exercise or not. And it could be possible, um, height and weight, height and sex, male and female. Very good. So height हो गया, what is that? Diet plan. So now we have seen, let's suppose just for example, with the age, height will get increased. So I am saying, like, these two parameter, why cannot be a single parameter? It's a very common parameter, right? This is called collinearity. Means whenever we are building any kind of machine learning algorithm, between the input feature, the variance should be very high. Means these two data points should not be highly correlated. Very good point. Whenever you are going to build any kind of machine learning algorithm, always remember two column should not be same. Two columns should not be so same means collinearity. Means this input feature say don't have any relationship, right? That kind of thing is called collinearity. Like now just try to understand if they this is very much dependent on the other feature. Like one independent feature is dependent on dependent feature, then there is a no means that is a blunder mistake, right? So that is called collinearity, right? How we can over how first of all how you will get to know this 2 point is the collinear. This 2 point is the collinear. So in order to know whether 2 point and 2 point not like that input one and output one, no, between the input and output quantity is there, then it's okay, but between the feature it should not be collinear. So in order to overcome this kind of problem, what we can understand, can we make understand some mathematical relationship which will tell us whether the your variable, whether the input feature are collinear to the other feature or not. Means some particular input feature is collinear with the other feature or not. So for that, we are going to introduce new term which is called variance influence factor. Let me talk about variance influence factor. So we are going to discuss about this VIF. So so we are going to introduce another thing which is called variance influence factor and how the variance influence factor works. 1 minute. Just a minute, guys. I'm wearing my specs. Okay, cool. So how the VIF works, let me show you. If VIF is very high, means your input feature one is dependent on other input feature, right? Means highly correlated. VIF is high, means that feature should be removed. So how I can show you? So what we are trying to do, so we are going to call the VIF variance influence factor of from the stats model. And now made it very much zoom. I have to remove from the zoom. Now I'm going to write variable and S scale, and VIF is equal to data frame. I'm creating the data frame, and in the data frame, we are going to create one column which is called VIF. And inside of VIF, what we are trying to do, we are trying to call variance influence factor. And inside of variance influence factor, I'm passing my x values, and variable comma I for range in the variable shape one, and we are going to pass these things into the variance influence factor. So with this, we will get feature name as well, x dot column feature name. And now if I'm going to run this code, now why after running this code, missing data error. XOG contain infinite and nans. Scroll the element text, adjust it. Yeah, it is not able to do. See data scrollable element or text editor. 1 minute, let me see what is this error. Axis field, we are going to make it axis cell. What is the data point? We have data now. We have this data. Very good. Now what I can do, I'll make a different column for this to make you understand. So here I'm going to import from stats, stat model, stats model dot stats dot outlier influence import variance influence factor VIF variance influence factor, and just come to this. X is equal to data. What are the different columns we have in data? We have GRE score. Number one, we have GRE score. Put inside a quote. Put inside a quote, comma. Again, we have one more column which is called. Okay, there is some none value is also present now in data. Okay, let me see what is this X then in that case. Okay, this is the data. And here is also null value present. We didn't remove the null value. We have just removed now. How we removed? There is no null value. Checking. हाँ ओके, डेटा में नन वैल्यू नहीं है. One minute, x and y is found. We'll print x only. Why is none value still showing? Can you see this? There is a still none value is there. That's what that error is coming. That none value have not removed yet. Can you see this? Is still none value is present. Just a minute. Yeah, we have removed these things. Did I ever describe? Can we do once again describe? Yeah, it is showing here. Okay, let me do one thing. Let me run once again this data. Building this model. If possible, I have not executed yet. And this thing is done, this thing is done. And now I have to execute this, right? Now we executed. Now if I'll run this, I should not see none value. Yeah, this is fine. Now we will remove the serial number. Remove the serial number. Serial number got removed. Data dot head. Now if I'll check, if I will check data dot head, and also if I'll check data dot describe, data dot describe. Describe, and here is I'm passing this. And if I'll execute, there is no null value. That is better. Now I'm going to remove this key error. Okay, it already removed, seems like. Now if I'll plot this graph, get plot, it got plotted, all these things. Now I will remove the x and y. Now if I'll see x and y, yeah, there is no null value. It seems like now it should work. Now it should work. Now standard scalar we are doing. X ka value we can remove it out. And now I'm going to take variance influence factor here. Just remove this line as well. And now if I execute this as well, now there will be no error. Yeah, now it ran successfully. Now if I'll print VIF, and I can see the VIF of GRE score to EFL score, university rating, SOP. This is my VIF value. This is my feature name. Now, with this VIF value, I can see there is no feature which having the VIF is more than 5. If your VIF is is equal to 5, more than 5, means that feature we should remove. Did you guys understood? So same thing I have been written here as well. Here we have the correlation value of all the feature as the thumb rule. The VIF value is greater than 5, means very severe. And multicollinearity. Multicollinearity means both the feature means two or more column are dependent to each other or same. So we don't any VIF is greater than 5, so we are good to go. Means we understood, right? If the VIF is more than 5, then that column we should remove. But in our case, there is no data point which having the VIF means variance influence factor is very high, but it's not high, so we should not remove any column in this case. Did you guys understood what is VIF? Very important question, like what is VIF? Why we are going to use this VIF matrix? हाँ बोलो बोलो. I'm asking with you all. अरे अभी पढ़ाए हैं. Just now I taught you. It is not like that कि I taught today and what is multicollinearity? What is multicollinearity? Means multicollinearity means one feature and other feature are very collinear, means both are same, means one is increasing, other is also increasing, one is decreasing, other is also decreasing. That thing is known as multicollinearity. Collinearity. So how we can check the multicollinearity? With the help of VIF as well. So with the help of VIF we can check the collinearity. So if VIF is greater than 5, then we can say the feature is very much collinear. So whenever you are going for interview, you have to prepare like this to give the answer. So just now I taught and you are not able to deliver the answer. Then what the sense of it is, right? So please try to answer. That's fine. Anyways, you are answering. That is more than happy, right? So let me talk about VIF. So we can see we no need to remove any feature, right? Because VIF is not get identified. Let's suppose if some of the feature VIF is high, then I can remove that feature, means completely remove and train our model with those features, right? So that's the thing. Now what I'm trying to do, we are trying to split our data set into two parts. One is train and another for testing. The same thing, x train, x test, y train, y test. Here we are using one library which is called train test split function, which is again a scalar matrix library provide this function train test split. And if you are passing your s scaled and test data test sorry y, and test size is 0.25, means 25% data I'm just keeping aside for testing, and remaining 75% data I'm going to make use as for the training. Now if I'll execute this, if I will execute this, this is done. And now if I'll execute this X train, Y train, I'm getting this. And also if I will, let me show you one more thing. I'm just printing the statement, print X train dot save. Okay, train dot save. Here I'm going to pass the message as well. Uh, in X train save, X train shape, comma this. Now if I'll copy this, control a C, no, not like this. Arey yaar, I'm not able to do how to zoom out from there. Similarly, I can use Y train shape, Y train shape, and here also I'm passing the message Y train shape. Similarly, if I will do X test shape, X test shape, and here instead of training, I can pass test, X test shape. I think I use the same name, right? Same name use की है. And similarly, I have to pass the Y. Ah, ah. Very much irritating this VS Code. And similarly, if I'm making Y test safe, and here I'm going to make Y test safe. Now if I'll execute this, and now you guys can see we have training safe 375, means X means independent feature, and 7 features are there. Similarly, Y terrain, we have 370 because it's only one. It's a 1D matrix. Similarly, X test, we have 125. And this is 120. There's 25% data for testing, and remaining 75% data is for training. Did you guys understood what we did? Just check the same. And now we apply the train and test. We distribute our data set into two parts. One is called train, another is called testing. Now I'm creating my regression model without any regularization techniques. Still, the regularization techniques is not applied yet. So I'm just creating the model and directly fitting my data, X train and Y train. And here I'm building the model. The model has been built. Now I'm going to save my model in finalize model.pickle. So here I'm just calling this model. I'm just pickle file. Okay, pickle is not imported, so I can import like import pickle, pickle. Okay, now if I'll do, now this model got saved into your system. This is your machine learning model, pickle file. That's a binary file, and you can see this model might get finalized model, right? Yeah, here will be finalized model. Can you see this finalized model? It got loaded, downloaded now. Now in the future, let's suppose in future I have to apply the prediction, right? I have to call my prediction. So for the prediction, we will not do again from the beginning itself all the sort of things. I will just load this finalized pickle file. See how we are doing. Forget about all the things above what we did. Forget about those things. Now I'm just okay. Let me show you one thing. I'm creating these things. I'm creating one more file here. Just test.ipynb file. ipynb file. Okay. Test.ipynb file. ipynb file. Now just observe here. I will not do all the model. I will just copy paste this line of code, import pickle and the file name. And here I'm just okay, it's dumping, it seems. No, loading the model. Sorry, this line of code. If I'll execute here, and here I have to import pickle, right? Import pickle. Yes, CKL, import pickle, and pickle we imported, and here we are passing scalar.transform. Okay, scalar model also we have to take it out. We have to store the standard scalar model as well. Just hold on. Scalar, where I did scalar. Here, Anna. So fit and transform, we did it. This we did now. So actually, ideally, what we should do here will be one more model will be there. Wait. There is one more model is there. I have to check finalize pickle file png. If I have downloaded that, this is also a model. We can store these things. So how we can store these things? Let me show you that part as well. Did I not save this model? Yeah, I can save this model as well. Just a minute. Control A, Control C. It might got removed somehow, but no worries. I can save this model, and here I'm making the model name as scalar, standard scalar dot pickle file, standard standard scalar 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 dot pickle file. And here I'm going to give this file name and here instead of this I can use this scalar function regression, and this is that function. That's all. And now if I'll do run this code, this file got saved, and you can see there will be one standard scalar.pickle file will get created. Can you see this, guys? Standard scalar.pickle file. Now I will use this pickle file here only. Same pickle file here also. So load load standard standard scalar scalar file pickle file pickle file. So here how we can load same pickle pickle dot load. By the way, I am using one thing. I am using GitHub Copilot. That's what you guys can see. I'm getting the suggestion as well. Can you see this? How many of you know GitHub Copilot, by the way? GitHub Copilot. GitHub Copilot is the AI tool. AI tool is like whenever you are writing the code, it will understand what do you want to write. Means it will give you the suggestion. That's the kind of thing. Okay. So yeah. And here also we can write, let's suppose, see, this file name is the error, right? So I can write here something right and writing finalize. It will automatically understand. If it is not getting a finalized, what is the file name we have taken? Just a minute. We have taken the file name, this one, finalize model.pickle. Finalize model.pickle. And here also scalar. Okay, instead of these things, can we write like this? This one. That's all. That's all. I think it should work. Let me see. Let me run this. Okay, again, it's saying base environment. I can call the base environment. And let me see whether I'm getting the prediction or not. It seems like it's connecting to the kernel. File not found. No such file. Standard scalar, std scalar pickle file is not. Oh, my bad. This is like chat GPT problem. Sorry, GitHub Copilot problem. It should be this file name. The suggestion was not right, right? Can you see the rename option? Guys, are you able to see the rename option? Actually, I have to come out from the Zoom. I don't know how to come out from the Zoom, but let's see, copy Control V, and then I will execute this once again. अरे यार ये क्या कर. And it should be PICKLE. PICKLE. This model is what? Pickle. So now I should get the result. Yeah, can you see this? This is the probability when your GRE score, TOEFL score, university rating is this much. Then see, did I loaded model? Did I train model again? I just loaded my pickle files. One is standard scalar pickle file and one is what? Finalized model. And I'm getting this result. With this function, I have to create an API and I have to serve into my application. Means what I'm trying to say, let's suppose you are going to build one application you have to build, right? So let me take a whiteboard. In any application we know two part is there, one is front end, another is back end, right? Correct me if I'm wrong. So you guys will be working as a backend engineer. So let's suppose you have to build a mobile application, and in this mobile application, front end guys are going to make a design. Here will be GRE score, here will be TOEFL score, here will be university rating, and blah 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 blah. And then user has to hit on this button submit. Then user will get a prediction result ki how much percentage chances is there that you will get a admission into the university, right? So this complete thing is getting designed by the front end. Now on this submit button, front end guy has to call one API, and that API you have to build. That's all. And this API logic is what? It's a means machine learning algorithm will get called like this. In this API, we are just calling. I will show you the API building. In this API, your responsibility is what? Your responsibility to convert this function into the API. Your responsibility will be to convert this into API, and you have to give this. I'll show you how to give this API. And that API you have to give this to this front-end engineer, and front-end engineer will call this API and they will show the result, whatever result you are showing here. Can you see this? This we are getting result here. Yeah. Did you guys understood what we did? So then front-end engineer will show to the client key what is the percentage of chances to get admission into the US. Yeah. Any question? Any doubt? I will show you the creation of API, but as of now, just try to understand. Now you guys understood how to create a model, how to save the model, how to load the model. Three things you guys understood. Now let me talk about the regularization, which is the agenda for today. Yeah, please. So pickle is the library. This pickle is the library which is responsible to load the binary file. Binary file means your model file, which you are creating in this folder file, linear regression. This file we have created here, and once you create it anywhere, you're responsible to how to load this model, right? So for loading, we are going to use the pickle. Okay. Oh, where is the so this is the loaded model, means your model, and with the model you want to predict what is the output. The predict is the inbuilt function. Any kind of model like linear regression, logistic regression, any kind of function, machine learning algorithm, there is a predict is the function to predict the value. Okay. Yeah. Control zoom in or zoom out. I have Control minus. Oh, nice. Yeah, I tried yesterday, but I don't know why it was. Anyways, it works. That is more than enough for me. Okay. So hope you guys understood, right? What is that? Means complete end to end. At least you are getting the idea. Now I'll talk about the regularization, but at least you guys got the idea key how the front end, how the machine learning model integration is happening into the real application. I will do show you the end-to-end application as well. One application we will build in front of you. Then you will get a clear picture, right? Now, see, you guys are asking what is this function? This function will come to know once you will do the practice. Write a code with your hand, with your finger, not see the presentation. Seeing the presentation, just I am going to explain the delivering the content, but you have to write the code. Let me give you one assignment, otherwise I'll forget. And whoever will done this assignment, honestly, I'm speaking, they are learning. They are learning. But if you are not able to means complete the assignment, then I am frankly saying don't join the class. It's just wasting your time, wasting my time as well. Linear regression, 2 hours continuously speaking is not easy thing. Just one day sit with me and start speaking for 2 hours, right? In your class I'm just spending 2 hours, but see, from 7 to 11, 7 p.m to 11 p.m again there is a one class, and that's coming to the end. Just I'm spending 4 hours in that class. Because of that class is coming to the end, there is a project session is going on. So just try to understand that 4 hours and 2 hours continuously speaking is not an easy thing. Just put the value on these words and just try, at least put your hand dirty. Just I'm requesting you, if you guys. Linear regression assignment. Let me give you one assignment to you. Yeah, I got one assignment for you. Let's see how many of you are completing this assignment. Your drive. Let me give the assignment. My job is to teach you and give the assignment, at least to so that you guys can make your hand dirty. But if you will not do the assignment, then it's your fault. I can't do anything. You guys are not a child. Day 13, it should be day 13. So side of this, I'm going to write an assignment, new folder, assignment, ASSIGMENT, assignment. Every problem statement, after problem statement, I will give you one assignment. That's my responsibility. And doing or not doing, it is your job. So this is the simple assignment. I have made it for you. Build a linear regression model using the scikit-learn Boston data to predict. And now you might ask, from where I will get this data? So to get the data, already given the command. It's a scikit-learn inbuilt data set. So this data set is to predict the home price. Means let's suppose you want to take a home for rent, right? So rent is getting affected by the multiple factor. Number of bedroom, how many bedrooms are available, how many washrooms are available, what is the location, right? Where I'm staying is a Kodmangla Salarpuria, right? So if I'm staying in this place, this is very costly. But if I'll go to towards some, Agara or somewhere like near to Electronic City, this cost will be less, right? So that's a depend on the location to location, the price will get varied. So this problem statement is about that. Like you have to predict what is the price of particular home based on the some input features. Did you guys understood this problem statement, guys? Yeah, very good. So I'm hoping coming class I will get one PPT, one IPYNB file with you all. Please do share. Once you guys completed, I am welcoming to see all your effort. Just put the effort. All the codes is already given. Just you have to replicate. That's all. Okay. Anyways, coming to the point, we are getting the score 84%. We are getting adjusted R square value 83%, means our model is 83% accurate to define all the data set. That's all. Now we are going to apply what we are going to apply lasso regression. Can you see this? Now what we are trying to do, this is again, it's a library. It's a library. Lasso is the library from the scikit-learn. You no need to write a code. Whatever mathematic derivation I showed you, like lambda into summation of beta, magnitude of summation of beta, means like that is already given, already implemented by this lasso function. Here we just need to pass CV, cross validation, maximum iteration, how many maximum iteration we have to do. Normalized true means like all the data will be normalized. Normalized means where the standard deviation will be 1 and mean will be 0. That 8 video, and I'm talking about from the 8 video. That's what I have given the 8 video yesterday, and I'm doing all the things. I'm not like that key directly speaking in front of you, like normalization. This term is clearly explained in the 8 video, in those 8 videos. So please already go through that. Normalized is not defined. Keyword argument not expected keyword. Okay, let me, I think it got updated. Let me remove that. Lasso regression. Okay, normalization has been removed by this new model. So now I'm going to check alpha value. Alpha value means lambda value. That lambda value, this is 0.0059. Now I'm going to call, create a lasso. Lasso I'm going to fit on this train, and now I will check the score is 75%. See, my score got reduced. Don't you think so? By applying the lasso, 75.34, and now it become, oh, training score, it is 75.30. What was that? 75.34, and this is 75.30. Okay, anyways, this score got reduced, means we should not apply the lasso in that case. Okay, let me show you why the reach. See, again we are calling the reach, and we normalization will not applied here. Also it will throw an error. Yeah, so we should remove this. Earlier it was available, but now they are not. So ridge regression is this. Now if I'll see alpha value, in this case 9.92, and here I'm just fitting this model, and if I'll check the score, and this score got increased. Can you see this? Earlier 0.7534, now 0.7571. Which one is the better, ridge, lasso, or normal wala? Answer me guys. Ridge, lasso, normal? No, ridge. How? Ridge. 75, 0.7571, and this score was 7530, and this was 7534. Oh no, 758 it is. No, it's adjusted R score. Sorry, this is 34. So this is always better, na? Ridge wala. See, ridge ka score is better than the anything. So we should go with the ridge. Now we'll call the elastic as well. Let's check with the elastic as well. Elastic regression, and if I'll see the score, L1 ratio, and if I'll check the score, this is 75.31. No, we should not accept the elastic regression. We should accept ridge. So go with the ridge. Your model is best, right? Okay, any question guys in this? This is the same, like it's another data set. Now I will show you the model deployment. This is the cloud model deployment. Okay, before wrapping it up, I would like to ask a few questions. Did you guys understood this concept, like what is linear regression? First question. Second question, did you guys understood what is regularization technique, ridge, lasso, and elastic search, elastic regression? And we understood how to define, how to call like offline model. This is called offline model. We trained our model, and now I'm sending this model for testing purpose. Means I taught you, and now I'm sending you to go for crack the interview, right? This is the same thing. I trained you, I prepared you, and now I'm sending you to in the market to crack the interview. That's the same thing. Yeah. Any questions, please? No question. Awesome. If there is no question, then I can go for like a model deployment process, right? And one assignment already given. Please try to build your own model for that assignment. And if you are able to build, then say congratulations to yourself. You are able to build first ever and first machine learning model, right? Now, I'm going to show you one more thing, uh, which is called model deployment. But before that model deployment, how many of you have the GitHub account? Everyone having the GitHub account? You don't have? So first of all, guys, please create your GitHub account. So GitHub account. And what is the GitHub? First of all, let me make you understand what is GitHub. GitHub is the shared code repository like a drive, Google Drive. In Google Drive, what we are trying to do? We are trying to store the things and doing all the sort of things so that in future we can use that. GitHub is also a same thing. How it works, let me explain that part. So next time onwards, we will start exploring machine learning model. uh, so let's suppose this is your developer. Multiple developers are working in one project, right? And every developer's job, they are writing their code into their personal system, into their personal system, into their personal system, right? Everyone is writing their code. And this, all the developers are working on single project, single project. To build this project, they are working on this code. But at the end, what? Their code, their code, their code has to be merged. Now, how I can access their personal system? Or also there is a problem. Might be tomorrow they wrote 1,000 line of code. This developer D1, this developer D2, this developer D3. These three developer write every day 10,000 line of code. But what will happen? Suddenly their system got crashed or OS got corrupted. Then that 10,000 line of code will got means destroy, and in that case we can't recover this code. That's very costlier process. So in that case, what we can do, we are going to use the shared code repository, SHARED, shared code repository, which is called, there is a different vendors are there which provide this service. Number one vendor, GitHub, it's a open source, and it developed by the no, it not developed by the Microsoft. Microsoft now it is owning, and they bought this application. Then there is another thing which is called GitLab, Bitbucket. These are the different kind of vendors, but job is same. BUCKET, bucket. So we are going to understand GitHub. All the obviously all the things are same, but only thing is the vendors are different. So what these guys are doing in the GitHub, every developer after done their project, means after their daily job, they are going to push their code into the shared code repository, which is called GitHub. And there is a senior guy who known as the senior developer. What this developer will do, they will review their code. This senior developer will review their code, and his responsibility to merge all those code. And at the end, tester, there is another one who is called tester, will test this code, and if this tester is saying it is okay, then we are going to push into the production. We are going to push the code into production. We are going to push the code into the production. And as soon as we are putting it into production, then again the here tester will come into the picture, and she will test the whole functionality into the production, and we are going to verify this is done. So for that, we have to know the GitHub. We have to create a GitHub account, and in that GitHub, we will push all the code into the GitHub, and we'll do. As of now, we don't have the, so this is called internship project. I will, in that, you will get to know how we can you work together, means multiple developer can work together in a single project. There will be senior developer, there will be senior data scientist people who can help you. Okay, what to do, what should not to do, all the sort of things is there. Yeah. Now let me show you that part. Just a minute, 1 minute. Okay. This is up to this. There is no doubt. You can clearly understand. Okay. Now let's create a GitHub account quickly, and then we can go forward. Anything has been open. Just go to the github.com. Guys, please do follow me. Github.com. I think it's already logged into my account. I'm going to show you into incognito mode. Control Shift N. github.com. Now, if you are opening the github.com, please, everyone, please create your account here. Open this website, github.com, in your system and follow me. I have shared the link into your system, into your chat window. So this introducing GitHub Copilot, I was talking about this. Your AI pair programming is leaving up, like you write the code. Okay, let me show you that part as well, how the GitHub Copilot works. It's a very, very awesome tool. I really like this tool. Just a minute. Here. So let's suppose if I'm writing write, WRIT, write. Can you see this? This is GitHub Copilot, code setting. So here I'm writing write a function to return a sum of two numbers. If I'm writing these things, if I'm waiting for this, it is not doing this. Okay, wait. It will do. GitHub links, git links. Or if you guys are looking for what I can say, free open source solution, then go to your marketplace and here search for Kodi. Cody, Kodi. This one. Kodi. This one, Kodi. In my case, it's already installed. Please install this. Can you guys install this? And I will show you the importance of this Kodi. In your VS Code, just go to the marketplace and search for Kodi and look for this symbol. There is a many vendors. Look for this symbol. And do let me know once you guys are installed. I will show you the importance of this. Are you guys doing? Anybody can confirm? Then I can wait. Otherwise, I can move ahead. Yeah, please do it. I think in your system, Thirumala, it's possible. It's organization request need, right? Acha, Kodi you already installed? That's good. That's very good. Okay. So now I can play with this Kodi. Just a minute. Disable. Where is the code? That's it. Are you guys able to see the option Kodi here? I'm not able to see. That's what. Trimala, can you please confirm in your system Kodi option is there and the right left section? Just see your VS code. There will be one Kodi option. I don't know why I'm not getting. Source graph Kodi. I got it. Yeah, I got it. So see, very important thing. So let's suppose if I'm write a function to add two number. So if I'm executing these things, and see, it will give you complete code, generalize an input, how to handle the decimal, support negative numbers, generalize an input. I'm passing generalize an input. And now see, अरे यार, other algorithm, some recursive solution. Let's see, generalize. It's presenting, I think. So see, it's a recursion way of summation, and this is also they have given the example sum. You can pass the list and it will give the total number. Like kind of code you can write, and also you can write a function. Uh, write WRIT, write the step to build linear regression. Let me see whether it is giving the answer or not. Build linear regression. Let's see. It's a free open source. It's still building. So see, sklearn, and it giving the whole step. Can you see this, guys? See, all code has been given. You no need to worry at anything. You just do the copy paste. Import sklearn linear regression, load the data. They have not given the data. You have to pass the data anyways. And you can do the pre-processing. You can do the sklearn test split. Call the model. Awesome. Just call the fit and transform. Oh my God. And then they are saying hyperparameter tuning. Don't you think so? This is the same thing what we learned here. This one. If I'm not wrong, go on front, go on top. This is the same thing. Hyperparameter tuning, export the model means saving the model. Everything is given. See, just copy paste and run this code. That's all. But it's not suggestible, but at least you have to know how the things AI is working. See, we can use the AI, but we should not rely on the AI. Then your job will be under difficult. We can use the AI, but we should not rely. And how many of you use the chat GPT, by the way? Anybody tried at least once? You used? Yeah, this chat, it seems like a chat GPT only. But chat GPT is the paid and it's a free one. Yeah. You can write a unit test cases as well with this. I can help you. Wait, I will show you. Means in some time, I'll show you the importance of Kodi. Please install Kodi. It's a very beautiful tool. Now I will show you how to create a GitHub account. So hope so everyone having the mail ID, right? Go to your this github.com website and click on sign up button. Once you click on sign up button, it will ask few questions. Enter your email. Please enter your registered email ID. Then see what, let's suppose I am going to press raj@gmail.com. If I'm passing this and if I'm clicking this, continue. Invalid email is saying. Acha, 111. Now I don't have this. Now it is asking to create a password. Create a password. Do it. It's like a creation of Facebook account, right? Just do it on this website. I will not create because I already have the account. Anush, I'm seeing guys, you are coming, going back. I don't know what is the problem. Is there any problem at your end? You can share with me. I might help you. Hmm. Are you guys creating? Okay, I am giving this task to you. Like create a AWS, sorry, GitHub account and be ready with your GitHub account. Okay. Um, by tomorrow, next class. Then I can show you the deployment. This is keeping to you. Okay. So yeah, with this, I'm going to wrap it up for today. We'll see tomorrow, means next class Friday. And with this condition, you have to prepare your assignment, and we have to prepare with the GitHub account, and then come up with these things. Then I will show you the deployment. Yes. Yeah, that's all, guys. We'll catch up then Friday, the same time.